Back to another video on double A learning. Today we're going to be sticking with the math concept and that being of calculus, and today's topic is going to be implicit differentiation. So even before we get into any practice problems, you guys need to know what the definition is of implicit differentiation. And so what is implicit differentiation? Okay, so what it is it is a way to find derivatives of a function, but when in the equation we have both x and y. Okay, that may seem like kind of sorry about that. Alright, that may seem kind of confusing right now, but I'll show you guys like an example of how it usually looks. So a type of question you guys may see is like x squared plus y squared is equal to 25. Alright, given the name, we know we have to differentiate. So, but the thing that's a little weird about implicit differentiation is that it's not in like the y is equal to x squared like form that we know. So, and before I get into the example, I want you guys to recall back to the derivatives video, and you can write derivatives as either y prime f prime of x or dy over dx. And I'm going to be using the dy over dx form, but you can write it in any form. I just find this one easier to do it when I'm doing practice problems. Okay, so let's get into some problems for you guys. Okay, so the first problem, we're just going to do the example that I showed. We're going to do x squared plus y squared equals 25. I feel like this is a good starter problem to like go over. Okay, what you first have to do is take the derivative of each of these terms. Let's just take the derivative of x squared, the derivative of y squared, and the derivative of 25. So how I like to do it is just take it on the side, d over dx, and then write x squared. So we know that is equal to 2x. And then, and we're taking these derivatives in respect to x. So make sure you guys know that. When we're doing implicit differentiation, it's in respect to x. 2x. And now we have to do d over dx times y squared. So that would give us 2y, but then we'd also have a dy over dx remaining. We're basically treating the y as a function of x. So we're basically treating it as a y of x. So that's why there would be the dy over dx over there. And then we would take the derivative of the last term, so d over dx of 25, and that would equal 0 because derivative of a constant is 0. So let's rewrite with what we have. So the x squared turns into the 2x, and then plus we have 2y, and we have dy over dx. And then that is equal to 0. Okay, what you guys want to do after doing this step is you want to solve for the dy dx, because we want to solve for the derivative of the function, and dy dx can be written as a derivative. So what we would have to do is we can move this 2x to the other side, so that becomes 2y times dy over dx, and that is equal to negative 2x. Okay, now let's divide the 2y. And we can cancel out these 2's because they're the same in the top and bottom. So then we can find out that dy over dx is equal to negative x over y for this problem. And that's your answer. So yeah, when you're using implicit differentiation, you're always you're differentiating every part with respect to x. So you guys need to make sure you know that. And also, use chain rule for any of the terms that include y. That's also important as we go along for more examples. And then after differentiating, make sure you guys just solve for the dy value. Okay, let's go to another example. And if you guys need more practice with this after the videos, I'll have a link to the practice worksheet in the description. Okay, so I'm gonna label this as 2. And then, so this problem is going to be x times y is equal to 10. Okay, what do we have to do here? So before I get into separating the terms and taking the derivative with respect to x, I want you guys to realize that x times y, that's the product rule. Product rule. And that's really important for you guys to realize, or else you'll mess up this whole equation. So in the product rule, we have to differentiate the first term and leave the second term, then differentiate the second term and leave the first term. So that's usually what you guys have to do in product rule. So and we basically have to do the same thing here. So let's just differentiate the first term. So we know the derivative, let's d over dx, oh god, let me rewrite that, that d over dx of x, that's just equal to 1. And we would leave the second term, so it'd be 1 times y. And then remember, it's product rule, so you're adding, and then you have to differentiate the second term. So the x would stay, and then we have to d over dx of y, and that would just be 1. But remember, since we're differentiating with respect to x, we'd have a dy over dx here. So I'm just gonna write 1 times dy over dx. You guys don't necessarily have to write the 1. I just write it just for clarity's sake, but yeah. Okay, then what you guys would do after that is take the derivative of the, with respect to x, of 10, and we know the derivative of a constant is going to be 0. So set this equal to 0. So now what do we have in our equation? So we have y plus, and then x times dy over dx. Okay, and that's equal to 0. Now again, we just solve for dy over dx. So dy over dx, that's being multiplied by x, I just rearrange the terms here, is equal to negative y. So now let's just divide the x, and that would be dy over dx, and that is equal to negative y over x as our final answer. So again, these problems, they can be kind of like a puzzle. They can be sometimes simpler, but some could be a little more strategic, where you have to use the product rule in this case. But yeah, let's go to another, our last example for today. Okay, so I'm gonna label this as 3. Okay, so our last example is going to be sine of x times y is equal to x plus y. This question, I would say, is more trickier compared to the last two that we did. So let's see how we solve this. So first, remember, we're taking the derivative with respect to x. So let's take care of this side first. So d over dx is equal, not equal to, d over dx of sine of x times y. Okay, so what will we do here? So first, let's just, we have to do chain rule in this case. So let's, I'm going to let u equal x, y. So we'd be differentiating sine of u, basically, times u prime. Okay, so then what we would do is sine of u, we know the derivative of that would just be cosine, and then times u, I'll use cosine u times u prime, and u prime, we have to take d over dx of x times y. Okay, so here, then we have to do product rule here. And we had done that before, so let's just fill in what we have. So cosine, I'm going to replace the u back with xy, and then times this part, which would be x times dy over dx plus 1 times y. Okay, that would just simply be our left side of the equation. So now let's worry about this right side. I'm just going to draw an arrow here. Okay, so x plus y. Well, this one's pretty easy. We can just differentiate this and this term. So that would just be d over dx of x, would that just be 1, plus d over dx of y, that would just be 1 times dy over dx. Okay, now let's just write all of our terms, just so that we don't get confused. So just on this side, we would have cosine of xy, then I'm going to do parentheses here, times x, and then dy over dx, and then plus y. Okay, and that would be equal to 1 plus dy over dx. Okay, now let's try to simplify this whole mess that we have here. So what I would do here is distribute the terms. So distribute this right here and distribute this right here to make it more simple for us. So this will become x cosine x times x in x cosine xy times dy over dx. I'm just going to do that in parentheses, and then plus y cosine xy, and that is still going to be equal to 1 plus dy over dx. Remember, our final goal is to solve for dy dx. Make sure you guys stay on that. Okay, what you would do after this is move this dy dx term here that we have here to this side, and we want to move this term that does not have a dy dx into this side. So what we would have to do, I'm just going to write it right here now. So that would be x cosine of xy times dy over dx, and then we'd have a minus dy over dx, because we're bringing this plus term over here, and that would be equal to 1 minus y cosine of xy. I'm going to write this on a new page because it's kind of getting a little messy, so let me just rewrite this. Okay, so what we had was, we had x cosine xy, and then dy over dx was here, and then minus the dy dx that we moved from the other side, and that was equal to 1 minus y cosine of xy. So that was what we had. Now what we would do is, we have a common of dy dx in both these sides, so you would take out a dy dx in this instance. So it would be dy over dx, take that out, so this would just be x cosine xy minus 1, and that would still be equal to whatever we have right here. So 1 minus y cosine xy. Okay, now in order to solve for dy dx, we just divide both sides by the top, divided by x cosine of xy minus 1, and do the same thing to this side. X cosine xy minus 1, and that gives us our final answer of dy over dx is equal to 1 minus y cosine of xy divided by x cosine of xy minus 1. So yeah, in the original equation, I'm just going to write it down here, was sine of xy is equal to x plus y. Yeah, so this question was definitely one of the longer questions for implicit differentiation, but it's definitely the one that could show up on your like quiz or exam. So just be careful when you're doing implicit differentiation that you take the rules that you already know of derivatives and apply them here. So I hope this video was helpful. Again, there will be a link in the comments below of the practice worksheet. So yeah, thank you so much.